All right, in this lesson, we're going to continue with sine and cosine function values, and this one's going to go pretty quick because at this point, you all should have this pretty down. So at the top of these notes, we're just going to recall real quick that the cosine of an angle is always equal to the x-coordinate divided by the radius of the circle that the coordinate is on. And then sine is the same thing, but it's the y-coordinate divided by the radius. So this should be review from the last video. If you rearrange these equations a little bit, we get that x coordinates are always equal to r times cosine theta. I just multiplied the r over to the other side. And then I can do the same thing with the y coordinate. Y should equal r times the sine of theta. So right here on our diagram, I've got this big set of parentheses here. That's because it is no longer x comma y when we're talking about angles on a graph. We're talking about r cosine theta comma r sine theta. All right, very good. Now, in this little video, we're going to be focusing mostly on the pi over 6 and the pi over 4 degrees. Ooh, that's actually a typo. Sorry. Pi over 6 and pi over 3 radians. Okay, there we go. Let's look at these first two problems here. It says for each problem, an angle in standard position in the xy plane is given in radians. A circle is centered at the origin with the given radius. What are the coordinates of the point of the intersection of the terminal ray of the angle and the circle? All right, so basically all we're trying to figure out is if we have an angle and a radius, what are the coordinates of the point on our circle? All right, so right here, this is really going to rely on you all memorizing your unit circle to the best of your ability. So I know using my formula, my coordinates should be r cosine theta, comma r sine theta. And in this case, I know r is 6, and I know my angle in radians is 5 pi over 6. So I can set this problem up like this. And now it's just a matter of remembering what cosine of 5 pi over 6 is and sine of 5 pi over 6 is. So if you have your unit circle memorized, great. If not, you might want to take a look at a unit circle. I know the cosine of 5 pi over 6 is negative root 3 over 2. And then I know the sine of 5 pi over 6 is 1/2. Okay, now, quick review. 5 pi over 6 is in quadrant 2. That's why the x-coordinate is negative and the y-coordinate is positive. All right, when I simplify to get my final answer, 6 divided by 2 is 3. So this is negative 3 root 3, comma, and then 6 times 1/2, that's 3. So this is my coordinate point. All right, and I can do something very similar over here. I want you all to try it on your own. So go ahead and pause the video, see if you can do that. And I will, of course, give you the answer in 3, 2, 1. All right, so when you set this up, you should have had that your coordinates are 7 times the cosine of pi over 3, comma 7 times the sine of pi over 3. And again, if you have your unit circle memorized, great. If not, you might want to look at one. The cosine of pi over 3 is 1/2, and the sine of pi over 3 is root 3 over 2. So there's really no simplifying I can do there. 7 times 1/2 is just 7 over 2. 7 times root 3 over 2 is just 7 root 3 over 2. All right, now these last three problems are the opposite. If you're given the coordinate, can you work backwards to find the angle in radians and the radius? And these, unfortunately, because we have two unknowns here, so I'll go ahead and highlight that for us. We have two unknowns. These are like very logical. You just kind of have to think your way through them. So if I look at this first problem, root 2 over 2, comma, negative root 2 over 2, that's actually already a set of coordinates on the unit circle. And of course, if it's on the unit circle, that means I know the radius is equal to 1. So right out the gate, I can say, okay, wait a minute, this matches some coordinates that I already know. My radius must be 1 unit. Then you just have to find what angle that this coordinate matches. So I know that the y-coordinate is negative, but the x-coordinate is positive. That means I must be, if I picture my unit circle, I must be somewhere in quadrant 4, right? These are all going to be negative y-coordinates and positive x-coordinates. Okay, and then the last thing I'll remember is that the coordinates are the same, which means I'm at one of those 45-degree locations. All right, so if I think about what is that in radians, all right, this I've got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So my theta value is 7 pi over 4. Okay, looking at this next one. Same thing, you're going to try and find something about the coordinates that looks familiar. So if I pay very close attention, I see that this is root 3 over 2. And I can rearrange this 3 over 2 real quick. I've got negative 3 times root 3 over 2. And then I've got negative 3 times 1 half. All right, so a couple things. First of all, both are negative, which means I'm going to be in quadrant 3. Next thing, I know the x-coordinate I'm looking for is root 3 over 2, and I know the y-coordinate I'm looking for is 1 half. All right, so that's going to be this angle right here. All right, so for that one, that's one of those pi over 6 angles. So once again, I can just kind of reason through it or use my unit circle. I can count it out. Pi over 6, 2 pi over 6, 3 pi over 6. We got 4, 5, 6. This would be 7 pi over 6 for our angle. And then my radius, it looks like both of those were multiplied by 3. Okay, so my radius is 3. Now be careful, your radius is not negative 3. The negatives just tell you what quadrant you're in, all right? You can't have a negative radius, just like you can't have a negative measurement of something. That doesn't make sense. All right, now this one is the hardest one, problem 5. But at the gate, you should recognize that you have a root 3. Okay, so if we really think about this for a moment, I'm looking for some number times 1 half, and I know that that gave me negative 2. All right. Sorry, I should say negative 1 half. There we go. Because my x-coordinate is negative. And then for this one, I'm looking for some number times root 3 over 2. And that gave me my y-coordinate. Now, how did I know negative 1 half and root 3 over 2? It really all just comes down to this root 3. All right. The only coordinates on the unit circle that have a root 3 are ones that have root 3 over 2. And if I know one of the numbers is root 3 over 2, that means I know the other one must be 1 half. Okay, so I got to figure out what times negative 1 half gives me negative 2. Well, I know that 4 times negative 1 half is negative 2. So I think this is what's going on here. And if the radius is 4 here, that means the radius must have been 4 there. And I can just double check and make sure that's right. 4 divided by 2 simplifies to 2 root 3. Yep, very good. Okay, so I know the radius for this one is 4. And now, once again, I'm just looking for the angle on my unit circle that matches these coordinates. So I have a -1/2, comma, √3/2. This is going to be in quadrant 2, so somewhere up here. And it's going to be that angle right there, which is 2 pi over 3. All right, so these are the hardest kinds of problems. You just kind of have to logically reason your way through them. But that is it for this video.